Good morning to all. I am Rajesh from ECE department at PSN College of Engineering Technology, Autonomous, Tirunelveli. I am going to teach about 8086 microprocessor architecture. First, we discuss about the introduction of 8086 microprocessor. So, first, what is meant by microprocessor? So, actually, microprocessor is a single chip IC. Microprocessor, single chip IC. It is a CPU only. Then, it is defined as a programmable semiconductor devices which fetches, decodes, and executes the instruction. This is called microprocessor. Okay. Here we discuss about the 8086 microprocessor. So 8086 microprocessor is a 16-bit processor. So this 8086 microprocessor is an enhanced version of 8085 microprocessor that was designed by using Intel in 1976. Next, it is a 40-pin IC. 8086 microprocessor, 40-pin IC. It is a dual inline packages. It requires plus 5-volt power supply. 8086 microprocessor requires plus 5-volt power supply. Here, the 8086 has 20-bit address bus and 60-bit data bus. So that means 8086 has 20-bit address bus. That means it can access up to 2 power 20. That means 1 megabyte memory locations. Okay. Next, it can support up to 64K input outputs. Next, it provides 14 16-bit registers. It provides 14 16-bit registers. Next, it consists of powerful instruction sets which provide the operation like multiplication and division. Next, here the 8086 support 2 modes of operation. First one is the maximum mode, another one minimum mode. So, maximum mode means it is suitable for system having multiple processor. So, maximum mode is suitable for system having multiple processors. Next, minimum mode is suitable for system having single processor. So, this is the difference between maximum mode and minimum mode. Next, it is available in 3 versions based on the frequency of operation. First one is the 8086. So it operates the 5 MHz frequency. Next, another one 8086-2. It operates in the 8 MHz frequency. Then last one 8086-1. It operates in the 10 MHz. So 3 versions of 8086. Next, it uses 2 stages of pipelining. First one fetch stage, then another one execute stage. There are 2 stages, fetch stage, then another one execute stage. This is the introduction of 8086 microprocessor. Next, we discuss the architecture. So this diagram indicates the 8086 architecture. So here in 8086 architecture is called pipeline architecture. 8086 architecture is called pipeline architecture. So here there are 2 functional units, bus interface unit, then another one execution unit. It consists of 2 functional unit, bus interface unit, another one execution unit. So here it is also called pipeline architecture because here the 2 functional units are work independently and overlapping. So it is called pipeline architecture. Okay, so 8086 called pipeline architecture. Which reason? Because here the two functional units are overlapping and work independently most of the time. So it is called pipeline architecture. Okay, so first we discuss about the bus interface unit. So what is the function of bus interface unit? So bus interface unit means fetches instruction, read data from memory and IO ports and write to memory and IO ports. Okay, this is the function of bus interface unit. Okay, so what is the function of bus interface unit? So bus interface unit fetches instructions, read data from memory and IO ports, write data to memory and IO ports. Next, here the first function, that means bus interface unit, consists of segment registers, address generation, then instruction queue. These are the elements of bus interface unit. Okay, so segment registers, address generation, then instruction queue. These three are the elements of bus interface unit. Okay, so in 8086 consists of 4 segment registers. Okay, what are the 4 segment registers? Yes, extra segment, code segment, stack segment, then another one data segment. Okay, here there are 4 segment registers. Okay, here that means the 8086 memory space can be divided into segments of 64 KB. Okay, here the 4 segment registers are used to hold 4 segment base addresses. Okay, so here in 8086, 4 segment registers are used. What are the 4 segment registers? Extra segment indicate the ES, next CS code segment, next stack segment SS, then another one data segment. These are the 4 segment registers. Okay, here the memory space can be divided into segments of 64 KB. Here the 4 segment registers are used to hold 4 segment base addresses. These are the segment registers. Okay, next address generation. The summation indicates the address generation. Here address generation means it generates the 20-bit physical address from the stack pointer and base pointer. Okay, then another one element is the address generation unit. What is the function of address generation unit? To generate the 20-bit physical address from stack pointer and base pointer. Okay, next instruction queue. It's another one element in the bus interface unit consists of instruction queue. So what's in the instruction queue? So instruction queue is the first in, first out group of registers. Instruction queue is the first in, first out group of registers. It contains 6 bytes. So this is the instruction queue. Then next element is the bus control logic. That means control system. Bus control logic. So bus control logic, all bus control signals. For example, read, write, signals for memory and input-output devices. So this is a bus control logic. Okay, so these are the bus interface unit. So first, what is the bus? So bus means group of conducting lines that carries address, data and control. So this is the bus. Okay, so first, what's in the bus? Bus means group of conducting lines that carries address, data and control signals. So this is called bus. There are 3 types of bus: address bus, data bus, control bus. Okay, 3 types of bus: address bus, data bus and control bus. So address bus means to carry the address signals. So this is the address bus. Data bus means to carry the data lines. Then control bus means to carry the control signals. For example, read, write. Okay, this is the bus interface, function of bus interface unit. Then another one is the execution unit. So this diagram in second part is the execution unit. Okay, here the execution unit execute the instructions that have already been fetched by the bus interface unit. Okay, so what is the function of execution unit? The execution unit execute the instruction that have already been fetched by the bus interface unit. Okay, so here the execution unit consists of general purpose registers, offset registers, arithmetic and logic unit, and flags. These are the elements of execution unit. Okay, so first accumulator register. First one is the accumulator register. So here the accumulator is divided into AH and AL. Okay, so here what is the function of accumulator register? So here the execution unit, the general consists of general purpose register. So what are the general purpose register? Accumulator register, base register, count register, and data registers. These are the general purpose registers. Next stack pointer, base pointer, source index, destination index. These are the offset registers. These are the offset registers. So first we discuss about the accumulator register. Okay, here it stores the 16-bit result of arithmetic and logical operation. So AH indicate the 8-bit higher order byte, AL indicate the 8-bit lower order byte. Okay, so totally it is called 16-bit registers. Okay, so it is called accumulator register. Clear? Okay, so what is the use of accumulator register? Store the 16-bit register, 16-bit result of arithmetic and logical operation. Next, base register. BH and BL indicate the base register. Okay, so what is the function of base register? It is used to hold the base value in the base addressing mode to access memory data. So it is the base register. So it is also 16-bit register. It is divided into BH and BL. BH indicate the higher order byte, base register higher order byte. BL indicate the base register lower order byte. Okay. Next, count register. So what is the function of count register? To hold the count value. To hold the count value in shift, rotate, and loop instruction. Okay, so this is the function of count register. Next, data register. DH and DL. Okay, so data register. What is the function of data register? To hold the data for multiplication and division operation. Hold the data, multiplication and division operation. Okay, so these are the general purpose register. Okay, what are the general purpose register? Accumulator register, base register, count register, then data register. Okay, so remaining register: stack pointer, base pointer, source index, and destination index. Okay, so stack pointer. So what is the function of stack pointer? To hold the offset address of top of the stack memory. Okay, what is the function of stack pointer? It is used to hold the offset address of top of stack memory. Okay, so this is the stack pointer. So what's in the stack? Stack means sequence of RAM memory location. Stack means sequence of RAM memory location. Okay, next one is the base pointer. Base pointer. So this is also switching bit register. Next, it is used to hold the base value in base addressing using stack segment register to access data from stack memory. So this is a base pointer. Okay, so this is also 16-bit register. Next, source index. So what is the function of source index? So it is used to hold the index value of source operand for string instruction. Okay, so what is the function of source index register? So it is a 16-bit register. It is used to hold the index value of source operand for string instruction. Next, destination index. Next register is the destination index. So it is also 16-bit register. It is used to hold the index value of destination operand for string instruction. Okay, so first 4 registers indicate the general purpose register. Next 4 registers indicate the offset registers. Okay. Next, arithmetic and logical unit, ALU. So ALU means to perform arithmetic and logical operation. To perform arithmetic and logical operation. Okay, so these are the architecture of 8086. So in 8086 architecture consists of 2 function unit. What are the 2 function unit? Bus interface unit and execution unit. Okay, then bus interface. What is the function of bus interface unit? So bus interface unit means fetches instructions, read data from memory and IO ports, and write to memory and IO ports. Okay, next, what is the function of execution unit? Execute the instruction. Execute the instruction fetched from the. So execute the instruction that have already been fetched by the bus interface unit. Okay, this is the function of execution unit. Okay, next, bus interface unit consists of segment registers, address generation, and instruction queue. Okay, these are the elements of bus interface unit. So 4 segment registers, address generation, next instruction queue. So instruction queue means first in, first out group of register. It contains 6 bytes. Okay, so 1 byte means 8 bits. So it's called byte. Okay, next, another one function unit is the execution unit. So in execution unit, here it consists of general purpose register, offset registers, arithmetic logic unit, and flags. Okay, in 8086 there are 9 flags are used. In 8086 there are 9 flags are used. Okay, what are the 9 flags? First one, sign flag. See the diagram. It's a flag structure. So this is the flag structure of 8086. Okay, so what are the 9 flags? First one, carry flag, parity flag, auxiliary carry flag, zero flag, sign flag, trace flag, interrupt flag, direction flag, and overflow flags. Okay, so what's in the flag? What's in the flag? Flag is a flip-flop to store the status of the processor in microprocessor. Okay, this diagram indicates the flag structure of 8086. Okay, here there are 9 flags in 8086. So 9 flags, what are 9 flags? Sign, carry flag, parity flag, auxiliary carry flag, zero flag, sign flag, trace flag, interrupt flag, direction flag, and overflow flag. Okay, so what's the flag? Flag is a flip-flop to store the information of status of the processor. Okay, here the 6 flags are affected by arithmetic and logical operations. Here, 6 flags are affected by arithmetic and logical operations. Remaining 3 flags, okay, flags are used for the control the processor operation. That means control bits. Okay, what are the arithmetic and logical operation flags? So carry flag, parity flag, auxiliary carry flag, zero flag, sign flag, and over flag. These 6 flags are affected by arithmetic and logical operations. Clear? Remaining 3 flags, that means trace flag, interrupt flag, direction flag. Okay, these 3 flags are used for the control the operation, control the processor. Okay, so first flag is the carry flag. So carry flag means it is set if the carry from addition, borrow from subtraction. Okay, if it is set means if there is carry from addition, borrow from subtraction. So this is a function of carry flag. It indicates the carry flag. Okay, so carry flag means if it is set, if there is a carry from addition, borrow from subtraction. Okay, next parity flag. So parity flag is set if the result has even parity. Okay, P indicates the parity flag. So if the result is set, that means 1. If the result has even parity, otherwise it is odd parity, that means 0. Okay, this is the parity flag. Next, auxiliary carry flag. So if it is set, if there is carry from low nibble to high nibble of the low order 8-bit of 16-bit number. So it is the auxiliary carry flag. Okay, what's the nibble? Nibble means 4 bits. Okay, so the auxiliary carry flag indicates the if it is set, if there is carry from low nibble to high nibble of the low order 8-bit of 16-bit number. So this is the auxiliary carry flag. Next is the zero flag. So zero flag means if it is set, if the result has 0. That means 1. The 0th bit that's indicating 1, the result is 0 flag. Okay, this is a 0 flag. Next, sign flag. So sign flag means if it is set, the most significant bit result is 1. The sign bit indicates the if it is 1, that means set, the most significant bit result is 1. Next, last one is next another arithmetic and control operation result, that it is overflow flag. That means if it is set, one of the arithmetic is overflow. That means the size of the result exceeds the capacity of destination location. Okay, but this is called overflow flag. Okay, so the overflow flag indicates the if it is set, if the arithmetic is overflow, that means the size of the result exceeds the capacity of destination location. Okay, these 6 are the control the arithmetic and logical operation. Remaining direction flag, interrupt flag, and trace flag. Okay, so here the direction flag indicates that means set 1. That means 1 for auto decrement. The direction flag is set 1, that means auto decrement. If it is 0, auto increment of source index and destination index register. Okay, this is the direction flag. Next, I, interrupt flag. I indicate the interrupt flag. So interrupt flag, if it is recognized, the external maskable interrupt. If it is 0, disable the interrupts. So interrupt flag is indicating 1 is the external maskable interrupts. If it is 0, that means disable the interrupt. Okay, next last flag is the trace flag. So this is used for the debug the program. Okay, trace flag is used for the debug the program. These are the 9 flags used in the 8086. So what are the 9 flags? Carry flag, parity flag, ancillary carry flag, zero flag, sign flag, and overflow flag. These 6 flags are used for the arithmetic and logical operation. It's affected by arithmetic and logical operation. Remaining 3, direction flag, interrupt flag, trace flags, these are the control bits or control the operation. Okay, these are the 9 flags. Next is the addressing mode. So it's addressing modes in 8086. So here there are 6 addressing modes. So first, what is in the addressing? So in 8086 there are 6 addressing modes. So what's in the addressing? So addressing means specifying the data to be operated by the instruction. So what's in the addressing? Specifying the data to be operated by the instruction is called addressing. Okay, here there are 6 addressing modes: immediate addressing, in-plane addressing, direct addressing, register addressing, register indirect addressing, next based index addressing. Okay, so first, what's in the immediate addressing? So immediate addressing means specifying the data to be operated by the instruction. Specifying the data to be operated by the instruction. Okay, so that means the data is the part of the program. For example, move BL, 26. 26 means data, 8-bit data. So it is a immediate addressing mode. Let's another one example. Move CS, 4567. So 4567 means 16-bit data. Okay. So immediate addressing. What's the immediate addressing mode? So immediate addressing means the data is specified in the instruction. The data will be part of the program. So it is the immediate addressing. Next, in-plane addressing. So what's the in-plane addressing? The instruction itself specifies data to be operated. Instruction itself specifies data to be operated. So example, set carry, STC. This is the in-plane addressing mode. Next, direct addressing mode. So direct addressing mode means the address of the data is specified in the instruction. The address of the data is specified in the instruction. So it is the direct addressing mode. See example, move CL, 9823. So here 9823 is the address, direct. Okay. So the address of the data is specified in the instruction is called direct addressing mode. Next, register addressing mode. So register addressing mode means the instruction specifies name of the register. The instruction specifies name of the register in which the data is available. So it is called register addressing mode. What's in the register addressing mode? The instruction specifies name of the register. For example, move BS, CS. That means CS data is moved to the BS register, 16-bit register. Then another one example, move CL, BL. Okay, so BL means 8-bit data. So store in 8-bit data. So the 8-bit data is moved to the CL. CL means count register, 8-bit data. Okay, so BS indicates 16-bit register, CS indicates also 16-bit register. Next, move CL, BL means so 8-bit data, BL register value is moved to the CL register. Next, register indirect addressing mode. So that means the address is specifying the indirect. So it is called register indirect addressing mode. Last one, base index addressing mode. Okay, so these are the addressing modes in 8086. So how many addressing modes? So 6 addressing modes. So immediate addressing mode, in-plane addressing mode, direct addressing mode, register addressing mode, register indirect addressing mode, and based index addressing mode. Okay, these are the addressing mode in 8086. So this diagram indicates the flag structure of 8086. This is the architecture of 8086. Okay, first introduction parts of 8086 microprocessor. So these are the architecture and instructions of 8086 microprocessor. Okay, thank you, students.